Students, this is a teacher summary for Unit 3, Lesson E, dealing with fractals and the golden ratio. On your ringlet reference sheet, there's two really important words you need to be comfortable with by the end of today's lesson. One is called an iteration, the other one's called a fractal. An iteration is just a repeating mathematical process. For example, let's say you have an input of x and your output is times by 3. So let's start with our input. X is 1, times by 3 is 3. Then you bring it up, you bring your 3 there. Times by 3 again is 9. Bring it up. 9 times by 3 again is 27, and your input, 27 times by 3, now you got to actually do the math here, and 9 times 27, that's going to be 63, 18, 246. Excuse me, not 9, 3. So times by 3, it's going to be 81. Okay, so that's an iteration. It's just a repeating mathematical process. Now, a fractal is simply a visual, some sort of visual of an iteration. A fractal is a visual of an iteration. They give you examples on your notes. Examples on, we're going to do it directly on Unit 3, Lesson E. So let's go here. You should have colors out in a straight edge. Here's your vocabulary for today: similarity, iteration, fractals, the golden ratio, symmetry, and something called the Fibonacci sequence. So an iteration is a repeating math process. A fractal is a visual representation of an iteration. Some sort of visual representation of an iteration which shows self-similarity. Which means you're going to have some sort of repeating factor which is going to be same shape, different size. So let me give you an example. We did this one on the notes. So if you have 3, and we're going to times by 4 this time. So 3, and we go times by 4 is 12. Carry up the 12. Times by 4 again is 48. Carry up the 48. And now we're going to take 48 and times by 4. That's going to be 2. Carry the 3. 16. 192. Now, right now that's just a series of numbers, but look at what's below. It's a visual representation of that repeating math process. Let's look at what you have here. Ready? I'd like you to trace the sides here. Trace the sides. How many sides do you have? You should have 3. Now, let's trace the sides here. Count. You should have 12. Wonder what's going on here. Let's try the next one. Very slowly, we're going to count and trace at the same time, starting from here. Ready? Let's go. 1, 2, 3. Keep counting. Trace all the way around and count. You should have gotten 48 here. Now don't panic. I'm not asking you to do that last one, but you should see here, see that we had the 3 and then the 12, 3 and 12, and then we went to 48. So you should see this last one, whether you count it or not, it has 192 sides. That's why we're not going to count it. We don't have a half an hour, but that's what it would be. What you're seeing here, this is a fractal. These are fractals. Now, there's a multitude of ways I could have expressed those numbers, and there's different ways to do that, but this is just one physical manifestation of an iteration. An iteration is a repeating mathematical process. A fractal is a visual of the mathematical process, which is self-similar. In other words, here, this triangle is the same shape as this triangle, which is the same shape as that triangle, which is the same shape as one of these triangles, same shape, just a different size. That's a fractal. Let's try another fractal here. This iteration, the repeating math process that we're going to do, is we're simply going to sum the number to the previous number. So here we started with the series 0 and 1, so 0 plus 1 is 1, of course. And then 1 plus 1 is 2. And now we add 1 and 2. We get 3. And now add 2 and 3. Of course, we get 5. And now add 3 and 5. We get 8. Let's do one more. 5 and 8. We get 13. Okay, so we just have a repeating mathematical process here, where you just take two numbers, you sum, you go on to the next number, you just keep going on and on. Let's try to make a visual of this. Let's see what we can do. I provided a grid. We're going to make some sort of visual here. So here we started with the 1. And we have another 1, so I'm going to put it right next to it. Now here we're going to do 1 to 2. So here it's 1 unit by 2 units. I'm going to go down this way. That is 1 to 2. Because that's what I have. I have 1 to 2. Let's see what else we can do here. Let's do 2 by 3. So here's 2. Let's do by 3 this way. So now I want you to make a rectangle that's 2 by 3. So that's 2 by 3. Now we're going to do 3 by 5. So here's 3 already. Now we're going to go 5 this way. 1, 2, 3, 4, and 5. Let's make that into a rectangle. So what am I doing? I'm just making a visual representation of our iteration. So then we do 5, and now we're going to go 5 by 8. So there's our 5 on the left. Now let's go 8 this way. 1, 2, 3, 4, 5, 6, 7, 8. Let's turn that into a rectangle, a 5 by 8 rectangle. And let's do 13. We have 8, and let's go down 13 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoop, we're going to run out of space there, 13. Turn that into a rectangle. This looks like a bunch of boxes here, but let's try something. Go really, really close in here to that central box. Let's try something here. And we're going to connect from one corner to the other in all the boxes. And I'd like you to curve it just a bit. Okay, ready? So connect those two corners and do a little bit of a curve. Now we're going to connect these corners here and here. Okay, see the purple? Let's connect here to here. Now we'll connect here to here. And connect where these corners meet. Now we're going to connect where these corners meet. What does that look like? You're familiar with this. What does this look like? That's called a logarithmic spiral. And that logarithmic spiral is something you should recognize in nature. Realize what you're looking at is a fractal. It is a sheer physical representation of a repeating mathematical process. But it looks like something in nature. Here's the connection I'd like you to make. Nature equals math. Nature equals math. Let's try one more. Another fractal. We're doing example 3. So for this one, we're simply going to do another iteration. We're going to do something. We're going to simply divide by 2. So I'm going to start with 1. And divide by 2. And I get 1/2. I'm going to bring this up here. Let me switch colors. And I bring that 1/2 up here. And so we're going to do 1/2 divided by 2, which is the same as 1/2 times 1/2. So divide by 2, we end up with 1/4. Bring it back up here. Repeating mathematical process, divide by 2. That's 1/8. Bring it back up. And 1/8 divided by 2 is the same as 1/8 times 1/2, and so I have 1/16. Now let's make a visual of that fractal. We start with 1. So let's make 1. Now we want to divide by 2, so we're going to take that, we're going to divide it by 2. So I'm going to divide by 2. And those halves, I'm going to divide by 4. 1, 2, 3, 4. And then each of those fourths, I'm going to divide by 8. 1, 2, 3, 4, 5, 6. What is going on here? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm not going to do the 16th on all of them, but basically what you're going to do is take each branch, if you were, let's just only do one, and now it's 1/16, so it's 8 on one side and 8 on the other. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7. Again, what you're looking at is a mathematical representation of a repeating process called an iteration. This is called a fractal. And you're like, that's not a fractal, Miss Way. That's a pine tree. That's my Christmas tree. That's my point. Math equals nature.